All right, so today we're going to talk about function notation and graphs. In your book, that is page 6, just so you know. I just want you to recognize what each of them, what they're talking about. So here, what the notation means in words is that f, who is the function, the variable will be here, and that will equal a certain amount that's on your graph. Okay, so this is actually the variable. That is what's given. It's the input. So maybe I would write input here. And then what comes out, the y, is the output. So we've got x is the given and y is the output. That's going to be important. So when they give you a graph, something like this, and they say f of 0, remember this is the input or the x value. Okay, so on the x-axis, when I go to 0, I have to hop up here, boop, boop, to find out where I am on the graph. Where I am is at 2. That's when y equals 2. So this is our output. This is our y value. Okay. For another example, what if they give me the output? So in this case, the output is 5. That's what that means. So on the y-axis, I'm like, oh, okay, so here's 5. 1, 2, 3, 4, 5. And I'm going to go over to my graph. Oh, there I am right there. My input then was 6. Okay, so what we're seeing is this, that if x is 0, y is 2. When y was 5, x is 6 on that graph. So over 6 up 5. See how that kind of matches? And that kind of gives us what we're going to be working with today. So what we're going to do is do a little bit of practicing. That was our introduction. Here's our practicing. Here's my graph. You'll see that this is the input, M3. So on the x-axis, I'll go over to 3. 1, 2, 3. There it is. And I drop down. Oh, here's my spot right there. I went down 1, 2, 3, 4 spots. So the output is -4. Or I could write it like this. My x value is 7, so I go over to 7, 5, 6, 7. There it is right there. And that means I didn't go off of the x-axis at all. You can see, so my output was 0. When they give that to us in reverse, something like this, remember this is my output. So that's the y value. On the y-axis, I want to be at +2, so 1, 2. Oh, there's 2 places that happens. That happens over here, and it happens over here. So I have 2 values. X is either at -2, or we also have 1, 2, 3, 4, 5, 6, 7, 8, because on that y equals 2 space, we have 2 spots. Okay, so let's keep playing that game. This is my input, 0. So on my x-axis, I'm at 0. Where is my graph? Oh, it's straight down right there at 2. One more time. Let me see if I can rustle up a different color. Here's green. My input was -3, so 1, 2, 3, backwards 3. My graph, it's way up here at +5. So again, what happens if they give me the output? Then I'm looking on the y-axis at -3. 1, 2, 3, there he is. And this happens twice, right here and right here. This happens when x is 1, and it happens again when x is 5. Okay, so we're just playing this game a tiny bit, expressing how things are. If our input was 3, our output was -4. If our input was 7, our output was 0. If our output was -2, our input was +2. See how that works? Whoops, okay, I messed that up. Boop, boop, like this. If our, oh, no, I said that right. If our output is 2, our input is -2. There we go. If our output was 2, we had another input, could have been 8. So these are points that we're talking about. Just practicing some more. So here's a group. This right here is graph A. I know that because that's what it tells me. So I want to know what happens when my input is 0. So here's 0, my input. My output would be -5. When they give us several graphs, we are going to have to kind of, I like to outline so I know what they're talking about, but separate them in our minds. So if they're talking about B, we're going to go over 4, 1, 2, 3, 4. Notice that we're not talking about this brown line, we're talking about this orange one. And we're going to go straight up, 1, 2, 3. Looks like it's crossing right there at +4. Okay. If they're talking about our C graph, so this one I'll do in green. Okay, C graph, my output is -3. So I'm going to go down here to -3. 1, 2, -3. And then I can go over to my graph, which hit right about here. It looks to me like he's halfway between -1, 2, 3, between -1 and -2. So I'm going to say that's -2.5 right there. Okay, so let's play that a little bit. We're going to use graph B, so this orange one right here. The output is 3, so 1, 2, 3. What is my, my output is 3, so 1, 2, 3. Oh, I'm crossing right here, which looks like 0 as far as X goes, because he didn't go left or right. Okay, now here's a fun, tricky one. I like this one. When does graph C meet graph B? So my green with my orange. Well, that happens twice. It happens once here and then again right there. So it happens at -5, 1, 2, 3. So, and then over here at 0, 1, 2, 3. So those are the 2 times that it happens. They don't meet again in other places. When does graph A equal graph C? So graph C, graph A, you can see that they're never touching. They're never crossing paths. So we would say no solution here. No solution. All right. So using a graphing calculator, I want to be able to show you, there we go. I want to be able to show you how we can use our graphing calculator to do a system of equations. So let's say these are my equations. So I'm going to hit my y equals button, clear everybody out, and I'm going to put in x squared. So this is my variable, x squared minus 2x, there's my variable again, plus 1. That light kind of made it harder, but there he is. Okay, I'm going to hit enter, and it will lead me down to the next line. So I'll go ahead and put in 2x plus 6. So I've got 2 equations in there. When we graph them both, we're going to want to find the solutions. So when I hit graph, look what happens. In my window, some of my window shows 1 solution, but I bet we meet again up here. So I'm going to change my window a bit. And I'm going to leave my x max and min the same, but I think I'm going to raise this up. Maybe make this -3 and make this maybe 20. Let's see if it shows 2 spaces that they're going to meet. Awesome. See, right here and here on that graph. There we go. So if I hit the trace button, you'll note that there's a little blinking light. I'm going to arrow over to one space where they meet. Now my numbers aren't perfect, but to me that looks close to -1 and +4. So first of all, you're going to sketch your graph. So I've got something that does something like this, and then a line, word. And what I'm looking for is those places where they meet. That wasn't a great sketch, but one of the solutions is about 1, 4. Whoops, -1, 4. There we go. And then if I hit or keep on my trace and just be like doo-doo-doo-doo and keep going until my blinking light, oops, reaches the next space. Again, not perfect, but I'm going to say that's about 5 and 16, right about there. You can double check that by plugging that in. If I put in a -1 here, 2 times -1 plus 6 more should get me 5. Or 2 times 5, which is 10, plus 6 should give me that 16. If you write down the numbers like this, that my calculator says, I'm still going to give that to you because that's as close as your calculator may get. So using the graphing calculator, you can show where those solutions are. Let's just practice one more time. Okay, so I'm going to go to my y equals button, clear these guys out. Okay, and then I'm going to put in 2x plus 4 and -3. Wait, that's trouble. That doesn't say y equals. So what I'm going to have to do is fix that. I'm going to have to add 3x to both sides. So now I have -y equals 3x minus 8. And then I'm going to have to get rid of that negative by dividing everybody by -1. So y equals -3x minus 8. Okay, make sure that he's in this form. If he's not, you've got to do some fixing. And that -3x minus 8 is what I'm going to graph. Oh, so these are just lines. I might change my window just a bit so that I can see slightly better. All right, and then use my trace button to get over there. So beep, 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 beep. Okay, I'm going to say right around -2. It looks like to me -2, 0. Not quite. Let's see. Maybe I'll window them in even more. Nope. I want -5, 0. And about -3, 3. Oh, see now when I trace, I got a little better visual. It looks like -2.4 and about -0.78. So that's what I'm going to write. Okay, when we do those solutions. All right, this is the last thing. There's a problem on your homework that uses a table. So they didn't graph it. They didn't even give you the function. They just wrote it out like this. Well, what I want you to remember is this is the input and this is the output. Okay. Input comes from this X group and output comes from the function or the Y group. Okay. So once you know that, My input is -1. So I'm going around here. There's -1. What's my output? It is 5. Okay, we're going to play that game again. H of 4. So I come over here. He's my input, and I've got 4. My output is 14. So when they reverse it and they're like, hey, take that, and your output is 8. Oh, I better find 8. And then they want the input. The input will be 2. Or on this one, the output is 17. So I'm going along. I see 17. His input will be 5, or his x value will be 5.